Welcome to Brain Vision.
In the first case, we have that for the electron, U minus E is equal to 0.0100 electron volts, and L is equal to 0.100 nanometers. So we'll go ahead and calculate the quantity C, which is the square root of 2m times U minus E divided by H bar, and then we'll just substitute in the quantities that we know. So we have 2 times the mass, and that's 2 times 9.11 times 10 to the minus 31 for the electron, times U minus E, which we know is an electron volts, and then we're going to multiply by a conversion factor from electron volts to joules, since we have everything else in SI units. And then we'll take the square root of all of that, and then divide by H bar, which is 6.626 times 10 to the minus 34 joule seconds divided by 2 pi. This gives us, for C, 5.12 times 10 to the 8th meters, inverse meters. So now we get the transmission coefficient, which is e to the minus 2cl, and this calculation can be obtained if we note that L is actually 1.00 times 10 to the minus 10 meters. So when we substitute that, we get 0.903 for the transmission coefficient. In the next case, we still have an electron, so we have the same value for the mass. However, the electron volts will be 1.00 electron volts, and L will be 0.100 nanometers, which again is 1.00 times 10 to the minus 10 meters. So C is obtained the same way as before. And we get 5.12 times 10 to the 9 inverse meters. Then we substitute in for the transmission coefficient the values for C and L, and we have e to the minus 2cl is equal to 0.359. Now we have a case for an alpha particle where U minus E is equal to 1.00 mega electron volts, and L is equal to 1.00 times 10 to the minus 15 meters, which is 1 femtometer. And the mass is 6.65 times 10 to the minus 27 kilograms. So we calculate the same way for C, but with these values. And we obtain the following. We get 4.374 times 10 to the 14th inverse meters. So now, when we substitute in e to the minus 2cl, we substitute C and L, and we get 0.417. In our last situation, we have 1 joule for U minus E. We have 2 centimeters for L, which is just 0.0200 meters, and we have a mass of 8 kilograms, 8.00 kilograms. And then we calculate in the same way as before for C. But we're going to obtain a very large number in this case. So we have 3.793 times 10 to the 34 inverse meters. And our transmission coefficient will then be, with e to the minus 2cl, we're going to get an incredibly small number as a result. E to the minus 1.52 times 10 to the 33. Now there is a trick to writing this in terms of a power as a power of 10. So note the following. E can be written as a power of 10. E is equal to 10 to some power p. So what you would do then is you take the log base 10 of e, which means that if you know e is equal to 10 to the p, log e is p log 10, which is equal to p. So p ends up having the value log of e, which equals 0.434294.5. And when you substitute in that value for p in the expression e equals 10 to the p, you can put that in for what we have obtained for the transmission coefficient. So we literally substitute in 10 to the 0.4342945 for e itself. And then this is raised to the power of negative 1.52 times 10 to the 33. This allows us to multiply exponentials. And now we'll have t as a power of 10. 10 to the minus 0.6601 times 10 to the 33rd, which becomes 10 to the negative 6.6 times 10 to the 32.